If you've ever tried to get an AI to do something really specific, I don't just mean write an email, but more like write a neutral email,
Yeah.
summarize these 2 points, definitely leave out that third thing, and keep it under 100 words.
Mhm.
You probably know how, well, frustratingly hard it can be for these language models to actually nail all of those little details. It feels like they get some parts but miss others.
Exactly. They can grasp the main idea, but those fine-grained constraints often get lost.
Right. So today, we're diving into a research paper that, honestly, offers a pretty brilliant solution to this exact problem, getting models to follow complex instructions precisely. Our mission is to unpack this new paper. It's titled, Checklists Are Better Than Reward Models for Aligning Language Models by Vijay Viswanathan and colleagues.
Oh.
And we're going to explore this novel method they've developed. It seems like it could really enhance how language models handle those intricate multi-step instructions we're increasingly relying on them for.
Yeah, it's about pushing for that next level of accuracy and precision, which is becoming more and more critical.
So maybe let's start by just quickly revisiting how these models are usually trained to see where the gap is.
Okay.
Typically, it's like a two-step thing, right? First, you have instruction fine-tuning, teaching the model to basically copy human responses.
Yeah, mimicry is the first stage.
And then, often, there's this refinement stage, using reinforcement learning from human feedback, RLHF, everyone calls it, that's often used to make sure the model doesn't say harmful things, or just to make it generally more helpful.
Right. RLHF has been really important for safety and general alignment, but there's a subtlety here that this paper really digs into.
Okay.
Well, while that RL approach works pretty well for what we might call verifiable tasks, things where there's a clear right or wrong answer, like, extracting a specific date from a text.
Right, something you can easily check.
Exactly. It really struggles with non-verifiable tasks. Think about ambiguity, open-ended requests, subjective qualities. That's precisely where complex instruction following often lives.
Like asking for a specific tone or a creative style with several constraints.
There isn't one single correct output. So the big question the paper tackles is, how do we adapt reinforcement learning so it works effectively even in these fuzzy subjective situations? How do we make it a general tool for getting the desired behavior, not just for easily checkable stuff?
Okay, so if standard RLHF kind of falls short on ambiguity, what did Viswanathan and the team propose?
Yeah.
Did they just ditch reward models altogether?
No, not at all. They innovated within that framework, which I think is really smart. They introduced something called reinforcement learning from checklist feedback, or RLCF.
RLCF, okay.
And the key difference is, instead of using these fixed, broad criteria like, is it helpful or is it harmless, which are kind of vague,
Yeah, very general.
RLCF uses flexible, instruction-specific criteria. It's tailored to each individual request. That's a really big shift towards precision in the feedback.
Instruction-specific criteria.
Yeah.
So like a custom feedback form for every single prompt.
Sort of, yeah. Think of it like this. First, the system extracts a really detailed checklist directly from the user's instruction. It breaks down that complex request into smaller, manageable requirements.
Right.
Then it evaluates the model's response against each item on that specific checklist. And it does this using a mix of tools, sometimes an AI judge, sometimes specialized little computer programs called verifiers for things that can be checked automatically.
Okay, so AI judges plus specific checkers.
Right. And finally, it combines all those individual scores from the checklist items to create a very precise reward signal for the reinforcement learning. It's not just saying good job or bad job. It's saying you nailed item 1 and 3, but you missed item 2, and here's why. It's much more granular feedback.
That sounds incredibly detailed. Breaking it down like that, it really feels like building a custom rubric for every single request. Almost like a mini to-do list for the AI itself, rather than just a vague goal.
That's a great way to put it.
But what makes an item on this checklist good? How do you make sure it's actually useful?
That's critical. The paper sets out clear properties. Each item on the checklist must be a yes-no question.
Okay, simple binary check.
Yes, and it has to be answerable just by looking at the model's response. And here's the kicker. A response is only considered fully acceptable if it satisfies every single item on that checklist.
Wow. Okay, so no partial credit for getting most of it right.
Yeah.
It has to hit every mark.
Exactly. It sets a high bar for actually following the whole instruction.
How do they actually generate these checklists? does a human write them?
Good question. They explored two automated methods. The first was direct prompting, basically asking another powerful language model, hey, look at this instruction and make a checklist.
Seems straightforward.
It is, but they found it often just kind of rephrased the original instruction without adding much useful structure. It wasn't always breaking it down effectively.
Okay, so maybe not granular enough. What was the other way?
The second method, which worked much better, they called candidate-based. Here, they'd get an LM to look at the original instruction and several different attempts by another model to answer it, some good, some okay, some bad.
So looking at examples.
Right. And the prompt was basically, identify the ways these responses fail to meet the instruction. It's focused on finding the failure modes.
Learning from what goes wrong.
Precisely. And this approach consistently produced checklists that were more objective, more atomic, meaning each item checked one specific thing and just generally higher quality. And that better checklist quality directly translated to better performance later on.
That makes intuitive sense. It's like debugging the potential issues up front.
And another neat detail. This candidate-based method also assigns an importance weight to each checklist item from 0 to 100, so it can flag which requirements are absolutely critical versus maybe nice-to-haves.
That adds another layer of nuance. Now, you hear a lot about models reward hacking, figuring out how to get a good score without actually doing what the user wanted. How does this checklist approach guard against that?
That's a very real concern. The paper specifically mentions including a universal requirement in all generated checklists to combat this.
A universal one. What does it check?
It essentially checks two things. First, does the response directly address the user's request without adding a bunch of irrelevant fluff or going off on tangents?
Okay, stay on topic.
And second, does the response match the appropriate context and tone? You know, is it professional if it needs to be? Is it neutral? Is it helpful in the way the user intended? It's a safeguard against just ticking boxes mechanically without fulfilling the actual spirit of the request.
Got it. So it tries to ensure genuine helpfulness, not just superficial compliance. Maybe an example would help make this concrete.
Sure. The paper gives one. Let's say the prompt is, list of Airbnb in Singapore for 2 packs less than 5,000 pesos per night.
Okay, quite specific. Currency, location, capacity.
Right. The RLCF-generated checklist for this might include items like, does the text provide a list of Airbnbs? Simple start. Then, are the listed Airbnbs actually in Singapore?
Verifiable.
Does each listing accommodate 2 people? Again, checkable. Is the price for each listing under 5,000 pesos per night?
Yep, another specific constraint.
These are all clear yes-no questions derived directly from that initial prompt, ensuring the model addresses every single part of it.
Okay, I can really see how that breakdown forces the model to pay attention to every detail. Now, you mentioned a precise scoring mechanism. How does that work?
Right. So after generating the checklist, RLCF uses this 4-step process for the feedback. The key part is the flexible scoring.
The flexible scoring.
Yeah. An AI judge, they used a powerful model called Qwen 2.572B Instruct. In the paper, goes through each checklist item for a given response and assigns a score, say 0 to 100, reflecting how well that specific requirement was met.
Okay, so a nuanced score, not just yes-no for the judge.
Right. But for things that are definitively verifiable, like, does the output contain the keyword Singapore, or is it formatted as a list? They use those specialized verifier programs.
It's a little checker.
Exactly. Those output a strict 0 or 100. And that score is then averaged with the AI judge's score for that item, if applicable. It adds a layer of objective ground truth for things that can be objectively measured.
Interesting blend. Why average them?
It seems to balance the nuance of the AI judge with the certainty of the verifier for specific factual checks. And to make the AI judge scores really reliable, they actually generated multiple scores. I think it was 25 for each item, and averaged those two just to smooth out any randomness or variance in the judge's assessment.
25 passes. Okay, they were serious about reliability. So now you have all these granular average scores for every checklist item.
Yeah.
How does that turn into the final signal for training the model? You mentioned preference tuning.
Yes, this is a really clever part. They calculate weighted averages based on those item scores, potentially using those importance weights we talked about earlier. But here's the critical filter. They look at pairs of responses to the same prompt. Maybe one good one not so good one.
Okay, comparing responses.
Right. And they only select the response pairs where there's the biggest difference in score on at least one of the checklist criteria. They specifically mention keeping only the top 40% of pairs with the largest score gap.
So focusing only on the examples where the difference is really clear. where the model can most easily learn why one response is better than the other.
Exactly. It's like focusing the model's attention on the most informative comparisons. Why waste time learning from pairs that are almost identically good or bad? Focus on the ones that show a clear distinction in quality based on the checklist.
Makes sense.
Yeah.
Maximum learning signal from the data.
hmm And they use this selected data for direct preference optimization, or DPO. That's a technique that directly fine-tunes the model based on these chosen versus rejected response pairs without needing to train a separate reward model in the middle. It's often more efficient.
Okay, that all sounds very well thought out. Extremely precise feedback loop, focusing on the biggest differences. So the million-dollar question, did it actually work? What impact did RLCF have on model performance?
The results reported in the paper are actually quite strong and, importantly, consistent.
Okay.
They tested RLCF on the Qwen 2.57b instruct model, applying it across 5 well-known benchmarks. 3 focused specifically on instruction following IFEVL, InfoBench, FollowBench, and 2 were broader conversational assistance benchmarks, AlphaGL and ArenaHard.
A good mix of tests.
And RLCF showed consistent improvements on all 5. For instance, on FollowBench, which measures complex instruction following, it gave a 4-point boost in the hard satisfaction rate. On InfoBench, another instruction following test, it saw a 6-point increase. And even on ArenaHard, which pits models against each other in challenging user prompts, it got a 3-point rise in win rate.
Wow, okay, consistent gains across different types of tasks. That's impressive. How did it compare to other automated feedback methods?
That's where it gets really interesting. They compared RLCF against methods using other reward models, like one called Skywork and another called ArmorM. Those other methods showed really mixed results. Sometimes they helped a bit, sometimes they actually made the model worse on certain benchmarks regression.
Oh, really? So not all automated feedback is created equal.
Not at all. RLCF stood out for providing consistent gains, whereas the others were much less reliable. It really highlights that the way you generate and use the feedback signal matters enormously.
So RLCF is clearly doing something right. Why do you think it works so much better? What's the underlying reason for its success, especially compared to those other methods?
The paper suggests a key reason is that RLCF is particularly good at helping models handle what they call content constraints.
Content constraints.
Yeah, think of these as the qualifiers in a prompt that really narrow down the acceptable answers, especially in open-ended questions, like the specific tone, or the points to include or exclude, or the format required.
The nitty-gritty details.
Exactly. The idea is that RLCF, by breaking everything down into a checklist, really incentivizes the model to pay attention to the entire instruction, every single constraint. Whereas other feedback methods, maybe because they use a single overall score, might inadvertently teach the model to focus on some parts of the prompt while ignoring others if it can still get a reasonably good score. RLCF forces comprehensive attention.
That makes a lot of sense. It prevents the model from kind of satisficing doing just enough to seem okay, but missing crucial details.
Right. And the paper includes some qualitative analysis looking at specific examples. That really drives this home. They show scenarios where other evaluation methods fall short.
Oh, like what?
Well, they gave an example of a standard AI judge using just a single broad rubric, like, is this a good translation? It might give the same high score to a perfect Spanish translation and another one that, looked vaguely Spanish but actually contained garbled nonsense from different languages. The single score wasn't sensitive enough to the correctness detail.
Ah, okay, so too broad. What about traditional reward models?
They showed reward models can sometimes be the opposite, overly sensitive to superficial things. Like, they might give wildly different scores to 2 responses that mean basically the same thing but are just worded slightly differently. It reacts too much to phrasing rather than substance.
Okay, so one is too blunt, the other too finicky.
Right.
How does RLCF handle that translation example?
RLCF, by combining that checklist approach with the AI judge and the specific verifiers, finds a better balance. For the translation task, the checklist would likely have items about grammatical correctness, correct language usage, maybe fluency. The verifiers could check for non-Spanish words. This combination allows it to correctly distinguish the good translation from the garbled one, providing a score that's both stable and interpretable, reflecting the actual quality differences based on specific criteria.
Right. That blend of specific checks and nuanced judgment seems key. Okay, this all sounds very effective, but what about practicality? You mentioned the AI judge doing 25 evaluations per item earlier. That sounds computationally expensive.
It definitely is. They acknowledge that. Generating these checklist-based judgments for their data set of 130,000 instructions took about 4 days using 8 high-end H100 GPUs, so it's not trivial.
4 days on 8 H100s. Yeah, that's significant compute.
But they also tested ways to make it more efficient. They experimented with reducing the number of scores they sampled from the AI judge for averaging. Remember the 25? They found that cutting that down to just 5 samples per item slashed the processing time by around 55%, a huge saving.
Wow, more than half the time saved.
But did it hurt performance much?
Encouragingly, it seemed to retain a lot of the benefit. While maybe not getting the absolute peak performance of using 25 samples, using just 5 still delivered significant gains over baseline methods, especially for instructions with simpler constraints. So there's a clear trade-off available between compute cost and the ultimate level of performance gain. It suggests the method can be made more practical.
Okay, that's good to know. There's a path towards making this more scalable. So wrapping this up, this deep dive has really shown how this idea, reinforcement learning from checklist feedback, offers a genuinely powerful and crucially consistent way to get language models to actually follow complex instructions properly. Breaking down requests into these granular, verifiable checklist items and then using that very precise filtered scoring, it just seems like a significant step forward from more general feedback approaches. I agree. I think this work really underscores how much you gain from having precisely defined granular criteria when you're guiding these models. It's moving away from hoping the model figures out what good means towards explicitly telling it what constitutes success for this specific task.
It shows that maybe the best way to guide these incredibly complex systems isn't just a general nudge, but a really detailed map.
Yeah, a map or a very clear checklist.
So maybe the thought to leave you with today is this. As we ask more and more of AI, perhaps the key to unlocking true mastery, especially for complex tasks, lies less in broad rewards and more in the simple, unambiguous clarity of a well-defined checklist.